So let's look at the Ankylosauria first. Their name literally means fused reptile because they have a bunch of vertebrae that are all fused together. So look at that big back area there. Those are vertebrae and then extensions of the vertebrae as armored plates, and they're all fused together as a solid piece. Sort of like, I guess you'd think like the shell of a turtle, but even far more armored than that. They also have what we call leaf teeth. I'll be showing you a picture of leaf teeth later, but basically, if you picture a maple leaf and the various little serrations or points on it, those are identified as the type of teeth that herbivores have. So this was clearly a plant-eating organism. It's also known for its very robust muscular limbs, built like a linebacker. The forelimbs are a little bit shorter than the back limbs. And we see this a lot of times in dinosaurs for groups that are eating plants on four limbs. So their butt is in the air, their face is pointed downward into the vegetation that they are eating, and their leg lengths identify that for us. Also, interestingly, they have hooves. Their nails on their feet have been rounded and enlarged or engorged to make these large hooves. They are oldest are from the MJ, as it says here, MJ, that's Middle Jurassic, and it is this Sarcoleptes. All of these things are herbivorous. So now let's look at the Thyreophora cladogram again. Remember, Thyreophora means just armor-plated or shield-bearing. And we have those primitive thyreophorans. Stegosaurs we'll get to in a minute. We're going to emphasize and talk about the ankylosaurs here. And the Ankylosauria consists of two families, the Ankylosauridae and the Nodosauridae. So, there they are listed right there, and here's a good place for me to tell you that we have to deal with these long and very convoluted and complex taxonomic terms, and sometimes they're very similar to each other. So notice the word Ankylosauria is very similar to Ankylosauridae. Ankylosauria is the big term that encompasses all of these things, and Ankylosauridae is going to be a subset of it. It's a family subset. And as I say here, yeah, it's going to be definite that you need to know these things, the differences, on an exam. So let's look at the other family first, the Nodosauridae. We have a whole bunch of these things, and one of the things they're really noted for is their very, very, very teeny tiny heads. Their heads don't have armor plating or horns. Basically, they're not armored up in the front end, the very front end. But then you can see, for at least for Polacanthus here, you can see some large extended armor plating over the neck and shoulders, and then big broad plating over the sacral or the hip area, and then more armor plating down here. So there's spines in this armor as well, and a clear distinction that is going to separate them from the other family is that they don't have a big extension or club end on the end of the tail. So all of these things are characters that distinguish the members of the family. So they would be distinguishing this line or lineage of the cladogram, but not this one. So that's the family Nodosauridae. Here's another example of these names being more complex and very similar to each other. There is, within the family Nodosauridae, there is the genus Nodosaurus, and we don't know much about it. We don't have the skulls, we don't have the spines, etc., etc. So why do we have it drawn like this? It's, again, an artist's reconstruction. So if we actually drew it out, we would not have the head end of this thing. Just don't know it. And then just rattle off some figures here this way. Now these things are contrasted with the Ankylosauridae, and you see there that we've got 9 genera of these have been found. And here notice that they are found in the Cretaceous only. So they are from the latter part, the very latest part of the dinosaur era. Remember, the 3 eras of the Mesozoic are the Triassic, Jurassic, Cretaceous. Go back here. So the Nodosauridae are found throughout this period, but the Ankylosauridae are found in the Cretaceous only. They are noted by a few things. One of the prominent ones is that their heads are highly armored up. So their temporal fenestrae, the holes in their head, are covered by armor. It's a protective thing. They don't really have much in the way of spines. And then notice as well, look at the end of their tail. Instead of being flexible, mobile vertebrae, sort of like a cat's tail flipping all around, these last few vertebrae are all fused together. They're locked or glued or cemented together so that he can wiggle the tail at the butt, but the end of the tail is a long stick, and then at the very end, look at this. This is a huge, big ball of bone. There's a scale bar that's 1 meter for scale. So for this thing here, this is almost 1 meter across of solid bone. Very, very interesting group. And when we talk about natural selection, so go back to that, the evolution aspect of what we're doing for Ankylosauria, you can describe these things as the Mesozoic tanks. They have clearly shown that there was natural selection for defense, armoring yourself up. It's as if, in an anthropomorphic sense, they've given up. We're slow, we're dull-witted. We just need to cover ourselves up in tough enough armor so that we're preserved from attack. They have a very wide rib cage. They're shaped like a barrel. Their ribs hang down, all of that. And that's basically it for the Nodosauria, the Sauridae, the more primitive group. The Ankylosaurs armor things up and do it that way. Here also you can see a nice picture of their leaf teeth. So they have a little nipping beak at the front end of the face, but then if you look at the teeth back here, and so this is enlarged, you see they have these sort of ridges, and they look like little leaves. And so picture a stalk of a plant sort of going in between here. These things would act nicely to sort of scissor it off, or they could sort of bite down and then pull back and shred all the leaves off of what they had. As far as defensive mechanisms, well, squat down, dig a hole, swing that armored tail around, which, as you can see here, again, was a very formidable weapon. Another aspect that is interesting about these two families, the Nodosauridae and the Ankylosauridae, is that there's natural selection that has shaped their faces differently. So both of them have paired tubes, just like we do, from the nose to the throat. But for Ankylosaurids, the family, notice it takes a huge S shape. So watch, so this is air being sucked in. It goes into the nose, it goes way back in the head, and then comes forward again and out here, and then exits this way. So they call this an S shape. It's just really a very convoluted passage. And then within this, there's a honeycomb of very complex cavities. They're sinuses with a whole bunch of little bones that we call turbinal bones, which are very similar to what mammals have. And I put a question mark here because those used to be one of the things that were distinctive or said to be distinctive of organisms that had warm blood, that they had these turbinal bones, but not so much anymore. But These things clearly had them. There it was. The nodosaurs, the more primitive group, again, air comes in, it goes back, it does the oxygen exchange, and it's out through the throat. But ankylosaurs, more like this. What could that possibly be? Why would there be a natural selection over time for this more convoluted nature? Remember, they're armoring up their skull, they're strengthening it, so just folding it over is like folding over cardboard. It makes it tougher. You could have more space for glands, moisten the air, improve the sense of smell, or noise making. A lot of our noise, our vocalizations come through our throat, but then they echo through our nose, and we certainly know that a lot of organisms will actually actively honk or blow air or make air go through their nasal passages and their mouth for vocalizations. Maybe it had that purpose as well. It's nice to sort of speculate on these things, but we just really don't know. Anyway, that does it for the ankylosaurs, the Ankylosauria. I'll be more proper here. And next we need to look at the Stegosauria.